Hi, hello dear students. Welcome to physics class. So we have been discussing the chapter dual nature of radiation and matter. So in the previous class we have discussed about the experimental results of the photoelectric effect conducted by Heinrich Hertz. So in detail we have studied about the experimental arrangement and working, and then we have discussed the 5 important experimental results of the photoelectric effect. How the first one, the photoelectric effect, is an instantaneous process. The minimum threshold frequency is required for the photoelectric emission. The intensity of incident radiation is, the photoelectric current is directly proportional to the intensity of incident radiation, and the kinetic energy of the photoelectrons is directly proportional to the frequency of incident radiation, and finally about the stopping potential. Now the next point we are going to explain here about particle nature of light. Particle nature of light, that is dual nature of light, we are going to explain here. Sometimes light exhibits as a particle nature. To explain the certain phenomena, light exhibits the particle nature, and to explain the certain phenomena, the light exhibits as a wave nature. So in particular, in certain situations, light exhibits the particle nature. In certain situations, it exhibits as a wave nature. So light has a dual nature, particle nature as well as wave nature. Now, by considering the particle nature of light explained here, that is the quantum theory of radiation we are explaining. That is in 1900. In 1900, Max Planck proposed the quantum theory of radiation. So according to the Max Planck, the electromagnetic radiation of frequency nu, right? The electromagnetic radiation of frequency nu. The electromagnetic radiation of frequency nu, it is emitted or absorbed in the form of tiny packets of energy, that is called as quanta or photon. Is called as what? Quanta or photon. Right? According to the Max Planck, the electromagnetic radiation of frequency nu, it may be absorbed or emitted in the form of tiny packets of energy called as what? The quanta or photon. Right? The light is made up of what? The light of frequency, the light radiation of frequency nu, which is made up of what? The tiny packets of energy called as quanta or photon. And they are emitted these energy. The energy of each photon is given by the relation E is equal to h nu. The energy of each photon is given by the relation E is equal to h nu, that is given by the Max Planck, and where h is called as what? The Planck's constant. Where h is called as what? The Planck's constant, and its value is 6.626 into 10 to the power minus 34 joule into second. Right? So this is the very important theory proposed by the Max Planck based on the quantum theory of radiation. And by using this Planck's quantum theory of radiation, Einstein explained the photoelectric effect. Right? The Einstein explained the photoelectric effect based on this Planck's quantum theory of radiation, and he explained what? The experimental results. The experimental results are explained by the Einstein based on this quantum theory of radiation by giving photoelectric equation based on law of conservation of energy. So first you have to understand what is the quantum theory of radiation, that is Planck's quantum theory of radiation. The light radiation of frequency nu, which is emitted or absorbed in the form of photon or in the form of quantum, and the energy of the photon is given by the relation E is equal to h nu, where mu is the frequency of radiation and h is Planck's constant. Its value is 6.626 into 10 to the power minus 34 joule into second. So now the next point we are going to explain here about the Einstein photoelectric equation and explanation of the photoelectric effect, the results of photoelectric effect based on his photoelectric equation. Right? Now before that, one more important point we have to study here, that is about the properties or the characteristics of photon. Right? So there is we have to explain here about the characteristics of photon. So in the examination you will get the 3 mark important question, that is write any 3 characteristics of photon. So right, now let us explain here some important characteristics of photon one by one. The first important property of the photon is the photon travel with the speed of light. The first one, photon travel with the speed of light. So you all know that the value of speed of light, right? So the first important property of the photon is what? The photon travel with the speed of light. So you know that the value of speed of light is 3 into 10 to the power 8, 3 into 10 to the power 8 meter per second. So this is what the value of speed of light and also what the speed of photon. The photon travel with the speed of light, that is equal to what? 3 into 10 to the power 8 meter per second. It travels with the same speed in free space. Now the next property of the photon is its rest mass. The rest mass of the photon is 0. The rest mass of photon is 0. The rest mass of photon is 0. That is also a very important point here. So the rest mass of photon is 0. So first one, it travels with the speed of light, and then the rest mass of photon is 0. And as we have mentioned in the quantum theory of radiation, the energy of each photon. The photon has a definite energy. The energy of each photon of frequency nu is given by. So here also the same energy property also can write here. The energy of photon, the energy of photon of frequency of radiation nu is given by, of frequency nu is given by, the energy of photon of frequency nu is given by E is equal to h nu. Right? So here the energy is quantized. So why it is called as photon? It is also called as what? Quanta. Right? Energy. It is also called as what? Quanta. Because of what? The energy is absorbed or emitted in the form of discrete levels. Right? The energy is emitted. There is no continuous emission or continuous absorption. There is a discrete absorption and discrete emission of the energy takes place. So that's why this photon is also called as quanta. Right? So there is a discrete emission or absorption of energy takes place. So that's why it is called as the quantized energy. It is called as what? The quantized energy, and the energy of each photon is given by E is equal to h nu. And the mass of photon, how we are going to represent here? The mass of photon is given by m is E is equal to m c square. So m is equal to E divided by c square, but E is equal to h nu divided by c square. So from the Einstein mass energy equivalence relation, you know that E is equal to mc square. Right, so m is equal to E divided by c square, but the energy of each photon is given by E is equal to h nu. Therefore, its mass is m is equal to h nu divided by c square. Now, the value of linear momentum of photon. The linear momentum of photon is given by P is equal to. So, from the de Broglie hypothesis, we are going to explain in detail about this. So, here P is equal to h upon lambda. So, here the lambda is the wavelength of radiation. Then its linear momentum is P is equal to h divided by lambda. Next, how the number of photons also we have to explain here. Its charge value we have to mention here. The photon is neutral. So as you know that the electron is negatively charged particle, proton is positively charged particle. Similarly, here the photon is, so proton is different. Proton is what? It is a nucleon, right? Here it is photon, right? The photon is electrically neutral. The photon is electrically neutral. The photon is electrically neutral. It doesn't have any charge. And finally, one of the important property of the photon again, as the intensity of the light increases, the number of photon also increases, right? The intensity is directly proportional to what? The number of photons. So the number of photons absorbed or emitted, it is directly proportional to what? Intensity of incident radiation, as we have mentioned earlier, right? The number of photons emitted or absorbed is directly proportional to what? Is directly proportional to what? The intensity of incident radiation. Intensity of incident radiation. So the number of photons absorbed or emitted, it is directly proportional to what? The intensity of incident radiation, right? So if the more is the intensity of light incident on the surface per second, right, then more number of photons will be there, right? Intensity of light ಜಾಸ್ತಿ ಇತ್ತಂದ್ರೆ ಏನ್ರಿ ಅವಾಗ number of photons ಕೂಡ ಅದರಲ್ಲಿ ಇರ್ತಾವೆ ಜಾಸ್ತಿ ಇರ್ತವೆ. That is a simple point. The number of photons incident on a surface per second, it is directly proportional to the intensity of incident radiation. So these are the important properties of the photon here. It travels with the speed of light, right? Its rest mass is 0 and energy of each photon is E is equal to h nu. Its mass is h nu divided by c square. Its linear momentum is h divided by lambda. It is neutral particle and the number of photons is directly proportional to the intensity of incident radiation. Now with all this, the discussion of Planck's quantum theory of radiation and regarding the discussion of the photon, the next point we have to explain here the Einstein photoelectric equation, right? So based on that, Planck's quantum theory of radiation, Einstein given the explanation for the photoelectric effect, the results of photoelectric effect, right? So first we will write the Einstein's photoelectric equation, then we will discuss about the explanation for the results of photoelectric effect based on Einstein's photoelectric equation. Now let us discuss here the Einstein's photoelectric equation. So based on the Planck's quantum theory of radiation, Einstein given the explanation for the photoelectric effect, right? So what is that explanation? Let us see here. So as you know that according to Planck's quantum theory, the radiation is made up of what? The tiny packets of energy, that is called as quanta or photon, and the energy of each photon is given by E is equal to h nu. So according to the Einstein, the photoelectric effect is due to what? The collision between the photon and the free electrons present inside the metal. So we have a metal here. So it consists of what? The free electrons. Consists of what? The free electrons. When a frequency of radiation nu, which is incident on a metal. Now, due to what? A photon of frequency nu, a photon of energy is equal to h nu, and the frequency of radiation is nu. When it incident on the metal, there is a collision takes place between the photon and the electron. Right? So, according to Einstein, the photoelectric effect is due to what? The collision between the photon and the electron. The free electron which is present inside the metal. So when a photon collides with the electron, the energy of the photon is transferred to the electron. So when this photon is collides with the electron, so the energy of the photon is transferred to the electron, and then when according to that the work function. What is work function? What is work function? The minimum amount of energy required to liberate the electron from the metal surface, that is called as the work function, right? So here there should be a minimum energy of the photon is required. That amount of energy should be what? Required to liberate the electrons from the metal surface. So ಏನಾಗ್ತದೆ ಯಾವಾಗ photon of energy is equal to h nu. Nu is what? The threshold frequency. Threshold frequency ಇರಬೇಕ್ರಿ. And the energy of the photon is greater than this. E is equal to h nu naught. H nu naught. So here nu naught is what? The threshold frequency, right? So when the energy of this photon is greater than E is equal to h nu naught, then there is a collision between the photon and the electron takes place, and the energy of the photon is transferred to the electron, and these electrons are liberated from the metal surface, or emitted from the metal surface, or ejected from the metal surface. So there should be what? The work function amount of energy is required, that should be incident on the metal surface. So when it is greater than the work function, then the amount of energy is absorbed by the electron due to collision between the photon and the electron. Then the electrons are liberated. So the extra amount of energy will be the what? The kinetic energy of the electrons. Now let us write here the Einstein photoelectric equation. So according to law of conservation of energy, if the energy of the incident photon is equal to E is equal to h nu, some amount of energy is required for work function, and some remaining energy is remained as a what? The kinetic energy of the free electron, that is liberated electron. So now let us write here, if E is equal to h nu is the energy of the incident photon. So energy of incident photon, total energy of incident photon is equal to energy of incident photon. The energy of incident photon is equal to work function plus kinetic energy of the photoelectrons. Kinetic energy of photoelectrons. So the law of conservation of energy should be satisfied here. If E is equal to h nu is the energy of the incident photon, so h nu naught is the work function, right? So h nu naught is the work function, that is denoted by the symbol pi naught. Then kinetic energy of the electrons. So maximum kinetic energy of the electron. So E is equal to h nu, it is the energy of the incident photon. The work function is h nu naught. Then remaining energy will be what? The kinetic energy of the liberated electrons. That we are going to write here. You know that the kinetic energy expression is half mv square. That is the maximum velocity with which the electrons are liberated. So how does the Einstein explain the photoelectric effect based on the Planck's quantum theory of radiation? Right? When a radiation of frequency nu is incident on a metal surface, when the energy of the incident photon is greater than the work function, the liberation of electrons takes place, the phenomenon of photoelectric effect takes place. E is equal to h nu is the energy of the incident photon. The total energy of the incident photon is what? E is equal to h nu, right? This energy is some amount of energy is used for what? The work function of the metal, right? It is what? The work function of the metal, the minimum amount of energy required to liberate the electrons from the metal surface. And then remaining amount of energy, the extra energy of the photon will be taken as what? The kinetic energy of the electron, and then it moves with the velocity v. So in this way we are going to explain here the Einstein photoelectric equation. This is the important equation we are going to represent here. This is called as the Einstein photoelectric equation. Here mu is what? The frequency of incident radiation. Nu is frequency of incident radiation. Frequency of incident radiation. And then nu naught is what? Nu naught is threshold frequency. Nu naught is threshold frequency. Nu naught is what? The threshold frequency. M is the mass of electron. M is the mass of electron, and V is the velocity of electron, ejected electron. Maximum velocity of ejected electrons, photoelectrons. Right, so in the examination we get the 2 mark question. Write the Einstein photoelectric equation, write the Einstein photoelectric equation and explain the terms involved in it. Right, so the energy of incident photon, it is equal to work function plus kinetic energy of photoelectrons. Right, so the photon of energy is equal to h nu, which is incident on the metal surface. There is a collision between the electron and the photon. That photon transfers the energy to the electron. Then if the incident energy is greater than the work function, then the electron will be liberated from the metal surface with kinetic energy half mv square. Right? So this is the important point regarding what? The Einstein photoelectric equation and explanation of photoelectric effect based on what? Explanation of photoelectric effect based on the Planck's quantum theory of radiation by Einstein. So finally, so there is an incident photon which is having the energy E is equal to h nu. This amount of energy incident agade metal surface. Adrolli some amount of energy agade work function agade. The minimum amount of energy required to liberate the electrons from the metal surface. Work function ಕಿಂತ ಕಡಿಮೆ ಎನರ್ಜಿ ಇನ್ಸಿಡೆಂಟ್ ಆಯಿತು ಅಂದರೆ ಎಲೆಕ್ಟ್ರಾನ್ ಲಿಬರೇಟ್ ಆಗಿದೆ, ಇದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಇರಬೇಕು. ಆಮೇಲೆ so after then what happens here, the remaining amount of energy will be equal to what? The kinetic energy of the electron. Extra energy ಏನು ಇನ್ಸಿಡೆಂಟ್ ಆಗಿರ್ತೈತ್ರಿ ಆ ಎನರ್ಜಿ ಆಗ್ತದೆ kinetic energy of the electron ಆಗ್ತದೆ. Then when it is having the kinetic energy, it moves with the velocity v, with kinetic energy half mv square. This is the maximum kinetic energy of the liberated electron. And this equation we can write in terms of wavelength also. You know that mu is equal to c by lambda. This is the relation between the wavelength frequency and the c, velocity of light. So here you can write h c by lambda, then H is the Planck's constant, mu naught is the threshold frequency in terms of what? Wavelength, that is C by lambda naught plus half m v square maximum, that is the kinetic energy of the liberated electrons. Alright. So all the energies here mentioned are in terms of joule. So here it is in terms of joule, energy is mentioned in joule, it is also joule and it is also joule. So energy is expressed in terms of joule. Right? So Hc by lambda, lambda is the wavelength of incident radiation. Lambda naught is again threshold wavelength and again half m square is the kinetic energy of the liberated electrons. So in this way the two forms of Einstein photoelectric equation we have written here. According to law of conservation, this equation is satisfied. So based on this Einstein photoelectric equation, now Einstein also explained what? Given the explanation for the results of photoelectric. So already we have discussed about the results of experimental results of photoelectric effect or the laws of photoelectric effect, right? Einstein explained the reason for the results of photoelectric effect, right, based on this photoelectric equation. In the next class, we will discuss about the explanation for the results of photoelectric effect based on his photoelectric equation. We will discuss about the explanation for the experimental results of the photoelectric effect based on Einstein photoelectric equation in the next class. Okay, thank you, students.